Hi guys, in this video we will cover codominance, and codominance is simply when both alleles are dominant, equally dominant if you like, and they are both expressed in the phenotype. For example, if we have red color and white color, in codominance they are both going to be expressed, so they will give us a pink color. The same can happen when we have black and white, they can give us a gray color. In codominance, of course, we change the way we symbolize the alleles. For example, we use two different colors. If we take like the red and white, for example, we are going to use two different letters, R being for the red, W being for the white, and we put these two letters on top of a letter, of an additional letter that we are going to use as a base. For example, in this case, I'm using the letter C, which stands for color, as the base, and on the top I'm writing R. So the color is red, and here the color is white. So we have two different alleles. So just by the symbols, you should be able to recognize that this is not a normal genetic cross, but it's a codominance. Now let's see an example of codominance. So imagine that we have these symbols, R for red, W for white, and we are looking for the colors of flowers. If we have a flower that has red color and we cross it with white flowers, then this is how the genotypes will be. This stands for red color, this stands for white color. The gametes here will be CR, the gametes here will be CW, so always the F1 will be CRCW. So it means that all of the F1 offspring will have a pink color. So all of the offsprings will be heterozygous. Now what happens when we cross two heterozygous plants? So we have CR, CW, CR, CW. So these are like, this is the F1. Now the gametes are CR, CW, CR, CW, and we follow the rules of a simple monohybrid cross. Okay, so now we're finding the second generation, so we're making our Punnett square, CR, CW, CR, CW. Here is my Punnett square. Now I'm making the genotypes, so this is CR, CR. This is CR, CW, CR, CW, CW, CW. So what do we have here? We have red flowers, pink flowers, white flowers. So this means that we have a ratio of phenotype 1 to 2 to 1. So 1 being red, 2 being pink, and 1 being white. The difference here in codominance with a simple monohybrid cross is that the phenotypes, when we cross heterozygous parents, is 1 to 2 to 1 in ratio, but in single normal monohybrid crosses the phenotype is 3 to 1. So by looking at the ratio, you can figure out if a cross is a normal monohybrid or if it's a monohybrid that involves codominance.